Hey guys, this is Tim from Tim's Electronics Lab, and in this video I'm going to show you how to make a soldering fume extractor and filter. Now, in order to make the speed of the fence adjustable, I'm going to use a buck boost converter. As you might have seen, I already tried to use the MT3608, but as you might have seen, that didn't work out very well, because if you turn the thermopod too low, the device will short circuit and it basically just blows itself up. So I looked around and the XL6009 was the only buck boost converter that I had laying around that was actually working. The other ones blew up. So here you can see me desoldering the potentiometer to be able to attach my own potentiometer to it. The stock board comes with a 10K 25 turn pot meter. To know which value potentiometer you want to use, you need to use the stock voltmeter and trim the output voltage to your desired output voltage, and then measure the resistance that your pot meter currently has. And based on that, you can create a table and you can calculate which potentiometer you want to use. Go ahead by soldering 3 jumper wires to the buck boost converter that you will later attach to the potentiometer. The polarity does matter, otherwise your potentiometer will be in inverse control. You can easily just flip the wires around if you experience that. Now you can solder the wires to the pot meter. Imagine that you place the pot meter on the PCB with the actual adjust handle sticking out, and that's the order that your wires should be soldered to the pot meter. Make sure to attach heat shrinks, otherwise the strain relief is not properly done and you might rip the cables off the pot meter later on, and that's not something that you want. And also it prevents short circuits. Now, before you put the heat shrink on and actually shrink it, you should give it a test to verify that the pot meter is actually functioning and that the voltage is actually getting adjusted. Now, if you find that the output voltage is not matching the range you'd expected, it's time to play around with different value pot meters. Change them, check which one does match your expected output or maximum output. And after heat shrinking the wires of the potentiometer, make sure to hot glue the wires that connect to the actual buck boost converter itself. This way you won't accidentally rip off the wires. Make sure to use plenty of hot glue, since I did not, and I ripped off the cables. Now, when that's done, it's time to solder the in and output wires to the buck boost converter. I use a standard PC power supply cable for this. You need 2 pairs, one for the incoming power and one for the outgoing power. Then it's time to attach the output power of the buck boost converter to the actual fence. Now I use a 60 by 60 millimeters 24 volts fan, and you can overdrive it a little. I think that my output is outputting 26 volts, and they perfectly accept that. It's within the tolerances of the driver circuitry. So for maximum reliability, I recommend that you actually solder the fence power wires together, and then you can solder the 2 power wires to the output of the buck boost converter. Don't forget to add another heat shrink to both wires, since 24 volt is not something that you want shorted out, since it will probably blow up your whole power delivery buck boost converter circuitry. So attach both wires to the positive and negative terminals of your buck boost converter, cover them with heat shrinks, and then we're going to prepare the case that has been 3D printing in the meantime. Clean it up, get rid of all the extra plastic, and start fitting everything together. Now the filter I'll be using is a charcoal filter that's used in fume extractors in the kitchen. Be sure to cut it with a nice sharp knife, and also be prepared because it will give quite a mess and your whole cutting surface will be black, as you can see right here. After that, it's time to fit the filter between the two filter holders, and in the end the filter will slide into the little grooves that you can see right here, into the little slots. I'm going to put the files on thingy first, but I will tighten or expand the slots for the filters since it's a very tight fit. Now my fans had some kind of foam around them, and I tried to fit the fans with the foam around it, but it just wouldn't fit. The fans need to fit very tightly in order to get the maximum performance, since if you've got any leaks, then yeah, there will be no vacuum effect and the air could also just come around the fans, which is not what you want, or it will get blown out when it finally enters the fan assembly and is inside the case between the fans and the filter. Then it will blow it out of the front, and you want to actually go through the filter and go out at the back. Be prepared, since trying to get the fans to fit will take some time and you'll have to do it multiple times. And make sure to not damage any of the wiring that's inside the assembly. Now the time has come to test it. I'm going to be testing it at various scenarios. One where the filter would be in normal conditions, and I'm going to use 4 settings of the fan speed, and we start with the minimum. And as you can see, it is not sucking up the solder fumes. I also tried blowing the fumes to the filter. That actually worked, but yeah, I don't like to blow the fumes into the filter. It should be sucking it up itself. Now I'm going to turn it up to 60% roughly. It's not entirely linear, and as you can see, the fume extractor is working a lot better. It's sucking up the fumes and it's pushing it through its filter. As you can see right here, it gets pulled in the direction of the air filter. I think that this setting is a good preset for the YouTube videos during soldering. I'll let you listen to the audio clip. Now at 90% it's starting to get really loud, but the effectiveness and the pull strength of the filter is quite amazing. As you can see, it immediately pulls the fumes into the filter, and without a doubt most of the fumes get filtered. Now the sound that this setting produces is way too loud for YouTube video recording, and you'll be all freaked out by the sound, as you can hear right now. Now the last preset is the full 100%. The fans are getting around 26 volt at this setting. I'm not sure about the effectiveness of 100% vs 90%, since 90% pretty much sucked up all the fumes already. So yeah, now we're going to do a test where the air filter is placed directly in front of the soldering iron. And as you can see, with 20% fan speed, it's starting to do something. It's doing way more than it did in the old setup. As you can see, some of the fumes get sucked into the air filter, but certainly not all of them. At around 60%, it's extracting way more fumes than it did at 20%, and the noise is also quite bearable. It's not annoying, but this scenario where the fan will be directly in front of the soldering iron is not your typical scenario, as there is no shielding in front of the fans. So if you accidentally poke the fans with your soldering iron or something, or your screwdriver, there's a great chance that one of the fan blades will come off. And at around 90%, it's starting to look like an actual hurricane. All the fumes get sucked up. No one is leaving into the environment, the air around the soldering iron, and it's pretty loud, as you were able to hear in the previous 90% test. Look, everything gets extracted. Now it's quite satisfying to see all the smoke disappear into the fan, because it basically just disappears. It vanishes between the high speed of the fan blades. And as you were able to see in the previous 100% test, there is practically no difference between 90 and 100%, except for a little bit more noise. The fumes also get extracted perfectly and very satisfying. So yeah, now it's time for a test of all the fan speed settings, where I just hold the soldering iron directly in front of the air filter and put solder on the tip. Now, as you can see, it's starting to get more efficient when the fan speed increases. Obviously, at 20% it's doing next to nothing, and 60% is really where it starts to pull in air, and at 90 and 100%, yeah, it's as effective as it would get, but also the noise increases, obviously. I've also made a sound comparison using an app on my phone. The ambient noise is around 44 decibels. And with that said, I'm going to leave you here. Make sure to check out the links in the description, where you can find all the project files. Thanks for watching, and I'll see you guys in the next video.